Today's new section comes from our textbook 3.5 and it's titled Finding an Equation of a Line. You can see we're going to be working with different characteristics and properties, all in context of a line, and we will have several different ways to show right lines when we're finished. So let's start with our good old friend slope. Our slope equation was always y minus y over x minus x. It's a true statement. You really don't need your subscripts as long as you're very careful about the order which you choose your points. But in this situation, if we replace slope with m and then said, well, this is an equation that we can solve, we would think of it like proportions, and we would cross product or multiply both sides by the quantity x1 minus x2, your choice, and you would get a new equation. This new equation would look like this. It is going to be typically called point-slope form in our book, but we'll change it just slightly. We will make it y minus y sub 1 equals m times x minus x sub 2, where we're looking at the x1 and the y1 will be where you put that point. So here and here are the x, y ordered pairs, and I said x2, it really should be x1 back there. So let me make that change real quick. x1, y1 is an ordered pair, it goes together. So the x and the y out front of those two highlighted values will stay as x and y. M, we already know, is our slope. So we should be able to put a value in there. So what are the different forms of lines we've already learned? Start thinking about that. This new one is called point slope. We'll show you how to use it briefly right here. If it says write an equation of a line that has the slope of 5 and goes through the point 2, 2. You could very quickly write your equation, generic form, y minus y sub 1 equals our slope times x minus x sub 1. And then decide that, oh yeah, according to the equation, y stays y, subtract y1. Our y1 value is a 2, so subtract 2. Our slope is a 5. X stays as x, the first x anyway, and then subtract our x value from our ordered pair, which is a 2. We would have an equation in point-slope form. All we did was substitute numbers in. There was nothing to calculate, nothing to rewrite. It's a new equation that you can use to help determine things about lines. So point-slope form, basically, that's one way we're going to be using it. All right, so which of these do we already know? And which one of them do you know, and which ones, and some of the characteristics. So let's see, forms of a line. Here's one. I think that's the one we just talked about. It's called point-slope form. You would enter a point in for the x2, y2 in this equation, and a value in for m. Another form of a line, y equals mx plus b. You should know that slope-intercept. You could enter a slope value for m and a y-intercept value for b. ax plus by equals c, also known as standard form, which we talked a little about in the last chapter. We've talked a little about in Algebra 1 as well. A, b, and c will be numbers, but by themselves they do not represent anything, but taken together in parts, they do. So review, opposite of a over b was the slope in standard form, c over b was the y-intercept, and c over a was the x-intercept. Okay, here's another one. X equals just a number. If you say that one, you should be thinking, oh, I'm a vertical line. All vertical lines cross through the x-axis, but they never go through the y-axis. All vertical lines have a slope of undefined, or we like to say no slope. Oh, there's one more here somewhere. There it is. Y equals a number is very similar to x equals a number. It goes the other way. It's our horizontal line. And again, we should know that all horizontal lines have a slope of 0. So, if I say write an equation of a line that passes through the point and is parallel to this equation, y equals 6x minus 11, there's a couple things you got to think about first. Think about meaning. If it's got to be parallel to this equation, then what makes it parallel? Most of us learn that having the same slope, and the slope in this case is a 6, so we're going to steal the idea that our slope has to be 6. After that, it says it must pass through the point negative 4, 5. So if it has to go through the point negative 4, 5, I'm going to look at my given information. I see a point, and I see my slope. So based on all the different forms of lines we just talked about, it sure makes sense to use point slope, the name of the information that's here. So memorizing it, we know y minus our y value has to equal our slope times x minus our x value. In this case, our x value is a negative, so minus a negative makes it plus a positive. There is our final equation for a line that passes through the point negative 4, 5 and is parallel to our equation y equals 6x minus 11 because it contains the same slope as that equation. Write an equation of a line that goes through the point 4, negative 6 and negative 3, 7. And then I have the 3 different main forms that we've used in the past. So taking them one at a time, there's something we need to do for all of them, and that is we don't have slope on this one. So I'm going to do 7 minus a negative 6, y minus y, over x minus x. Follow the math. Y minus y, 7 minus a negative 6 would be 7 plus 6, or 13, over x minus x, and that would be negative 3 minus 4 would be a negative 7. So it's looking like our slope is negative 13 sevenths. Knowing we have that, we will probably want to write this equation if we go standard form first. We have our slope. We don't want to play around with the other ones. Some people say, well, can I write it in slope-intercept first? I suppose we could. So if you want to do part B here, we can go y equals, if we have our slope, 13 over negative 7, we don't have our y-intercept value, and neither one of the given points is a y-intercept. So you could put in one of the 2 points and solve it that way. So if we did that, let's put in negative 3, 7. So y equals, if we put in our slope of negative 13 sevenths, and then plugged in our x value of negative 3, we don't have our b value. That's what we're going to be solving for. And I forgot to put our y value in up front. So let's erase this y and substitute it with our y value is 7. Whoops. Got to change my color. Okay, so looking at this, we'd probably have 13 over 1, or 3 over 1 here. So we would have a negative 39 over 7 plus b. We have a whole number of 7 on this side, but since we already have 7s here, it makes sense to turn this into 7s. So 7 over 1 would turn into 7 sevenths is 1 whole, so 49 sevenths. And if we bring our 39/7 over and join by adding that to both sides, our b value will be equal to 9 and 9, 18, carry the 1, 88/7, and we end up with a final answer of y equals 13, negative 13/7 x, plus we just found our b value to be 88/7. Slope-intercept form is one where you are going to have some fractions around. You're not going to have all whole numbers all the time. As long as your fractions are in lowest terms, you're good. Now, let's steal our slope before we move forward, and let's go to actually C, choice C. Point slope form is probably one of the easiest. So 13 over negative 7 was our slope. And remember, you could say negative 13/7. And this time, since we did B on the last one, we're going to do point slope on this one. A nice easy one. Point slope says take either one of your points. We have a point here and we have a point here. And we've already calculated the slope, so we know that that's negative 13/7, and place it right into your equation. So we'll have y, if I use the first point, y plus 6 equals our slope times the quantity x minus our x value. That's one choice. Or you're saying, well, I don't like that point. I really prefer this other point over here. So you would write y minus 7 equals our slope times x minus a negative 3 would be x plus 3. And either one of those equations would be acceptable for an equation in point slope form. Okay? All right. Last but not least then, we should have our standard form. And remember, standard form really meant ax plus by equals c, but we got some rules about standard form that we have to talk about. So let's go back and use our last point slope equation using this second point, because it was fairly simple. Y minus 7 equals our slope, negative 13/7, times x minus a negative 3 would make it plus 3. Okay, so that was one of our point slope forms. So we did point slope, we did slope intercept, and now standard. Standard says ax plus by, which is the x and the y term, must be on the same side of the equation. It also says you can have no fractions. And it would like you to have your a term positive when you finish. So let's finish first. We can't have these parentheses, so let's distribute. And we would get negative 13/7 x, and then plus a negative 39/7. Now, if we got to have our x term and our y term on the same side, let's go ahead and move this x by adding a positive 13x to both sides, 13/7 x to both sides. And at the same time, we could move this negative 7 as an add 7 to both sides. Okay, after having done that, you still have a lot of fractions floating around. And as we said, in standard form, we like ax plus by equals c to be no fractions. We want a, b, and c to be integers. So at this step right here, it makes sense to go ahead and multiply every single term, because our denominator is a 7 all the way around. Make every single term 7 times bigger, which will help us eliminate our fractions. So we're going to have 13x plus 7y equals 49 plus a negative 39. And we can finally do any addition or subtraction that still remains, and that would be our 49 plus negative 39. So our final answer of 13x plus 7y equals 10 should be our equation in standard form for this line. Probably writing something in standard form is the most difficult because it does allow a few more restrictions. You can't have fractions, wants that first term to be positive, all types of things like that. So now we've done all three of them. And then I have one more question, as you've been seeing here. What is the name of a graph that is made from parts of lines? And if I would just reset this page for a second, it might be something that looks like this. It was in our book already. Horace's bike trip was an example of one. We do something like this, and you come down, something like a graph like this. Those are all pieces and parts of lines, also known as line segments. What is the name of a graph that uses those? We've had it several times, and it's included here again. It is called a piecewise linear graph. So I bet you're going to see one of those along the way in your problems today. But if it's a particular problem, you can ask about them in class. That's all for now.